All right, this is section 3.2, part B. And what we're going to do is we're going to simplify expressions again. And this time, instead of just a number under the cube root, we're going to have a letter, a variable. So we can automatically do the cube root of 64 because that is a solid 4. But when we get to this 6 here, the easiest thing for you to do is take 6 and divide it by 3. And when you do that, and you can get a whole number, you just pull it out of the cube root sign, and this would be it. All right, here we have a few more things, and I notice inside the parentheses we cannot combine anything. So I'm going to apply this 1/3 onto every single thing in here. And so I did it to the 27. When I multiply by a 3, I get 1. So P is to the 1 power now. And Q would be 12. It's actually 12 times 1, which is 12, divided by 3, which is 4. And then I look to see if I can do anything else with this. And if I change this to the cube root of 27, I know that that's actually a 3. And so my answer is 3p q to the 4th. Okay, now we have two variables here, and we're taking the 4th root of each one. Remember, you can divide this up into two separate problems. And you want to check to see if you can divide this number here by the root, and in this case you can. 4 divided by 4 is 1, and then 8 divided by 4 is 2, so you would have n squared on bottom. All right, now this one we have several different variables going on, and when we're dividing, first let's start with our numbers. We have 14 divided by 2, which is 7. And then when we divide the exponents here, remember that is a 1, we have to subtract. So 1 minus 3/4, and if you put this in your calculator, just as that is, you get the decimal. And when you switch it back to a fraction, it should equal out to 1/4. Okay, so now x has a 1/4. Okay, and if we're going in alphabetical order, we would go to the y next. Y is really, there's nothing we can do with it because there's nothing on bottom. And this z has a negative exponent, so it's going to go on top and become positive. And this is actually the answer because nothing else can combine. All right, so if we go through this problem here, we have the 5th root of 4, which we cannot do anything with. The 8 divided by 5 will not give us a whole number. 14 divided by 5, same thing. But 5 divided by 5 will give us a whole number, and we can pull that c out. And so right now we have left over everything else. Now before I go through and write the leftover part, I want you to realize that you can break that apart. Our goal is to try to get an a to come out of there somehow. So if you think about 8, we know that 5 plus 3 equals 8. So if we broke it apart and put 5 and then 3, and then for the 14 as well, we know that 9 plus 5 would be 14, and we already got rid of this. So now you can see, because we broke it apart, we're adding fractions here. It still means it's a to the 8th, but now we can pull out an a because 5 divided by 5. So we have an a that can be pulled out. We also have a b that can be pulled out because 5 divided by 5. And I want you to recognize something else. This number here is a 9, and I can still break that down. So yes, over here, I still have this C, and I have the 4 under here with the A to the 3rd, but this B to the 9th is now going to be 5 and then 4, because 5 plus 4 is 9, and now I can cancel that out because 5 divided by 5 is another B. So instead of just plain B, I added one to it, which makes it B squared. So now we only have the A to the 3rd and the B to the 4th. You can always check your answer too, because if these exponents here are smaller than 5, you know you can't really go any farther. If they're bigger than 5, you know you can keep going. And so here is your final answer. All right, this one's a little different. I'm going to first divide it up into 2 separate problems. Okay, this one, yes, you could break down the y to the 8th and go as far as you could possibly go. You could also do a different way as well by multiplying this bottom by one more y. And the reason why I'm doing that is because I know that 8 plus 1 is 9, and 9 can be divided by this cube right here. So on top, I also have to multiply by a y, which will just give me xy underneath there. And then on bottom, this will transform to y to the 9th, which will then 9 divided by 3 will just be a solid y to the 3rd power. Because remember, we don't want radicals on the bottom. Now let's say you chose to do it the other way, and I just want to show you this way, just in case you don't like what we just did. Let's suppose, and remember this is all on bottom, let's suppose that you broke this down and you said y to the 3rd and y to the 5th, which is still this 8. You could see that you could take out one of these y's. But you still have this y to the 5th in there. And then you go to the next step, which would be to break down this 5. So 2 and 3, which then again you would also take out another 3, or another y, I mean. Okay, so now we have y squared with this. Notice how we're still left with a radical. You would still need to multiply by a y here, both top and bottom. So there's no way of getting around this process. It was much quicker to do the top way by adding 1 instead of breaking it down. So I just want you to see the difference between the two. You're still going to get the same answer if you continued on with this, but look how much more work there is. I would go with this method. Remember, we are adding and subtracting, so we're going to add and subtract like terms. And if you can tell here, these are kind of like the variables. And so if we have 1/5 of them plus 3/5, we have 4/5 of these square root of w's. And so this process can be a little bit easy as long as you recognize that we're adding like terms. Again, here's another example. The like terms here would be the xy to the 4th. And so we have 3 minus 8, which would give us -5 of these xy to the 4th. And the last problem, this is a little bit more complicated version of this. Okay, you notice that we don't have the same like term after the 12 or the z, and not only that, but the 12 doesn't have a z over here, so we wouldn't be able to add like terms just like it is. Let's do something though. I noticed that this 5 is bigger than the root here, so I'm going to break this down and say z to the third and z squared instead of this 5. Because 3 plus 2 is 5. This is just a different way of writing it, which means I then can pull out this z because it cancels. Okay, so now I have a z, and I have a 2z squared over here under in the root, the cube root thing. And if I look over here, I do have a z, but I have 54z squared, and I need 2z squared. So let's just go ahead and divide 54 by 2. You could do that in your calculator. And when you do that, you get 27. And so we have the cube root of 27 times 2z squared. We know the cube root of 27 is 3. So that gets pulled out. And now we have left over the cube root of 2z squared. And as you can tell, these are now like terms. And so are these here. So we say 12z minus 3z, and that is 9z. And then we just write the like term right after it. Okay, that was it for this video, pretty short one, and you can now finish the assignment. And remember, it's every other even.